Hello and welcome to another video. We're going to be doing some coding of some sorting algorithms in Java today. Let's share screen so that we can kind of get started. I think to start off with, all we're going to do is we're going to kind of think about the things that we need. So let's make a new file called say bubble sort.java. Okay, so first we're going to start with some basic algorithms to sort. Now, bubble sort basically sorts an array of integers, let's say. I'm going to utilize integers as my sorting data. It's going to sort them in ascending order using a bubble sort algorithm. Now, it'll take in an integer array as an input and then sort it in ascending orders. Basically, it will iterate over the array from index 0 through n-1, n being length of array. Then we'll have like an inner loop that iterates over the unsorted part of the array between the index of 0 to n minus index minus 1. So length of the array minus a index, the outer index, minus 1. So within this inner loop, two adjacent elements are going to be compared and then swapped if they are in the wrong order. So I'll just keep going and repeating until the array is fully sorted. It's a fairly simple algorithm. It's not very performant in comparison to other ones, but it's a good starting point to just get into the idea of sorting. So let's jump on in and may as well just open this up in VS Code or whatever. Feel free to open this up in another IDE or something that you want to use. I'm just literally opening this up just for simplicity instead of having to make a whole project and do other stuff. So let's think about this. So bubble sort, let's write some general docs for this, let's say. So thinking about this, this is gonna sort. It's gonna sort an array of integers in ascending order using the bubble sort algorithm. Yeah. So we're going to be having a parameter of, let's say, ARR for the array. And that's going to be the integer array to be sorted. There we go. We've got some basic sort of doc string there now. Now that we've got that set up, let's think about this kind of concept that we want. That's what we want to do. And we're going to insert this into a class in a moment. But for now, I just want the actual concept of what we're doing. So we'll make this public, static, void, bubble sort. And remember, it's going to take in an integer array called ARR. Okay, so bubble sort. Typos for the win. Seriously. Okay. So now we've got this static function or method and we're going to say, okay, well, I want to find out what's the length of the array. Now we can do that with the ARR.length as a property. So what I can do, I can just say, well, I wanted to kind of speak about it as n. So I'll say int n is equal to the length of the array. So the size of the data that we're bringing in. This will be good when we're talking about the big O notation and the time complexity as well, because we usually reference via something of n or something of n squared or n log n or something, different sorts of references in that way. So the int n is going to be useful in that descriptive term. Now I want like an outer loop. So I can just do a simple for loop. And I want it to loop until it hits n minus 1. So I'll say, well, I is less than n minus 1. We can then increment I. Okay. Now, on an inner loop, like I described earlier, where we go up to n minus I minus 1. So now we're going to go for int j equals, j is going to actually just equal 0, so I'm kind of going over each set. Then it's while j is less than n minus I minus 1. Then we can do j plus plus. Right, so now we've got our structure. We've got our looping, what we're going to do. Some of you may have already noticed what the time complexity is going to be on this, just looking at that code. If you haven't, don't worry about it. We can talk about that afterwards. So at this point, we're going to say, well, hang on, what was it we need to check? We need to check each individual pair of numbers and see whether one is larger than the other. So here's where we can say, well, okay, I can use an if condition for that. I'll say if ARR at j is greater than ARR at j plus 1, then just move it. You want to swap those things. You want to swap, what is it? We want to swap ARR at j and ARR at j plus 1. So that's what we want to do. Now, to do this, we can make a temporary variable. This is simple. We could write a whole swap function and do other things. But now we can just make a new integer called temp, which is going to hold the initial value at ARR of j. Then we're going to set ARR of j to a new value, which is just going to be ARR at j plus 1. Now that we've done that, we've still got our temp array, so we can now say, well, hang on, now I want to insert or change out my ARR at j plus 1 to be equal to temp, which is basically what ARR at j was. At this point, we've now swapped those two values, so it only does it if it's greater than. Otherwise, just leave it on that. And that's really the basic algorithm itself. It's all, I'm not going to say completely self-explanatory, but it's fairly easy to follow when you kind of get to grips of it. As long as you understand what a for loop is, how nested loops work, and general indexes or indices, and a simple if condition to swap things based upon one value being greater than the other. And that's it. So in essence, it's doing exactly what we described in the first place. Now, as far as time complexity is concerned, if we are measuring on order of n, so length of the array, we can say, okay, well, it has to loop at least around about, well, n minus 1 iterations at least there. Then it also, under here, it also kind of does pretty much sort of an n minus 1, but not. It's got a lot of things, but we could say, let's work out the different things. So this is a order of 01. That's saying it doesn't matter how long the array, this is going to take the same amount of time to do, setting the variable. This is technically boiled down to order of n. This is also, we can technically boil down to also a linear sort of order of n. And if conditional, doesn't really matter what sort of data you've got there, going to be constant time. Each one of these are also going to be constant time. Okay, so we've now got this constant time things here. So we could add all these up and kind of make a sort of supposition of what these are. So we could just say, okay, well, in that case, I'm going to say that if we just start adding all these up, let's look at what we've got. We've got all these constant ones. So we're going to take all these constant ones. So we've got order of 1. Yeah. But how many times have we got that? We've got it once, twice, 3 times, 4 times, 5 times there. We've got 5 order of 1s. Okay. So it's order of 1 times 5 plus order of n. But then we've got an order of n nested inside an order of n. So it's squared. It's to the power of 2. So it's actually plus order of n to the power of 2. Okay. Now, if we think about this, we now need to remove any multiplicative constants. So that lot can go away. So now we need to take these two things and go, well, which one is the most costly out of these two things? And as you can see, constant time is super fast. It doesn't matter however sized it is, it's not going to change the speed, like the time complexity of the algorithm. So that can be kind of negated because it's not as heavy in weight as this here. So we finally end up with a sort of a worst case scenario of order of n to the power of 2, or n squared. So here we have the algorithm of quadratic runtime. So our bubble sort is quadratic runtime. Okay. Now here again, this code would not directly run as it is. For Java, we need it to be inside a class with the same name as our file. So let's do a quick wrapping of this in a class. So we'll say public class bubble sort. With a capital B. And we'll grab all of this. Put it inside there. Now we could make a public static void main, giving it a string array of args. And we could maybe make some driver code for this just to make it do something. So in essence, we can call this bubble sort. We can say bubble, or we could if I could type. Call bubble sort here. And we could pass it in an array of integers. Okay, so we've got an array of integers passed in. Yeah. So that would give us bubble sort. Now it doesn't actually see. Notice how we're not really sort of going, okay, well that's great, but we're going to lose this thing. So this needs to be an actual variable here. Yeah, it's not spitting out the data that's sorted. In this situation, we're doing kind of an in-place sort. So what we can do is A is equal to this, and it needs to have a typing. So it's going to be an int array. So what we can do is a couple of things here. This may need some refactoring, but then we're just going to say A. So if we were to do like system.out.print line of A, it's the one before, then do a bubble sort and do the same again. Do something similar to that. May need curly braces for this initializer list, but we'll see if it decides to be a bit more smart with what it's doing. Right, let's see what we get here. We might get an error now on compilation because I'm kind of visualizing things and maybe slightly pseudocoding some of this whilst we're talking. But let's see what errors we get. Let's save this. Let's now open a new terminal. See what we can do. Let's do a Java compilation of bubblesort.java and see what it's moaning about. It's going to moan about that illegal start of expression. So it doesn't like the idea of us having a literal array. I can't remember whether we can do an initializer list like we would in C++. Let's give that a quick go. It's been a while since I've just manually, there we go, instantiate it in that way. So now we could do Java bubble sort, and it gives us not what we'd like. It gives us, well, it gives us that we're talking about the same array. So now what do we need to do to actually look at this? Think about this. This is an object of type integer array. When we try to do a string of an integer array, it gives us the memory address. Notice it's got I at this memory address. So pause the video and think about what it is that you need to do to print this object, or at least the data inside it. And unpause once you've sort of made an idea in your head and thought about it, and kind of say it out loud and think about this a little bit. Okay, I'm going to presume you've unpaused the video by then. So here we've got this thing, and the idea here is we need to like iterate over each of these elements and print them to the console. So to do that, we can just do a simple for loop. Let's do simple while I is less than a dot length. And then we can literally go, okay, well, now I want to print this out. But we don't want to print out A, we want to print out A at the index of I. And then we want exactly the same thing here. So we can just go do this and have a look. So copy that, pop that out of the way, pop that there, and clean up the index. So let's recompile it. And let's run it. And let's take a look at what it's given us. 2, 3, 1, 4, 7, 6, 5, 8, 9, 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it has sorted it. Obviously, it's not the clearest of things if we've got those numbers. But what we could do here is we could maybe make it a little bit clearer in the sense of that. And don't do a print line. Let's do a print. Yeah. And in between those, we can do a system.out.print line. An empty what's-it, just to give it a new line. And same again at the end of this. And if we wanted to, we could also go, okay, in that case, what I'm going to do is I'm going to say, do the same here, but I'll say unsorted data. And then we can do another one of this. So look, it's been unsorted data like that. And then we'll say sorted data. Okay. Save that. Recompile it. Rerun it. Unsorted data. New line. We still need another new line there, so that's fine. It's just, we could, you know what? Let's just, instead of adding new stuff, let's do a \n, say new line before we say sorted data. Compile it, run it, unsorted data, 2, 3, 1, blah, blah, blah. What we could add here is perhaps add comma space. This is not going to be the most ideal thing. No, you know what? I'm not even going to do that. I'm gonna add a space after it, so just so you can see the different things. Or yeah, I know exactly what I'm going to do. Just want to make it look a bit tidier or different. I may need to do some type running in this or some casting. Don't know whether it's going to cast it for me. There. I think might just get away with something like that. I'm going to just see if that works. It may moan at me about trying to, type conversion stuff, but let's give it a go. So that looks quite nice. So I'm going to do exactly the same sort of concept with the other one, just to give it some more semblance of these are different elements. Again, this is all just visuals. This is not really relevant to the actual algorithm. It's just, oops, oh, might help if I actually compile it first. There we go. So our unsorted data is 2, 3, 1, 4, 7, 6, 5, 8, 9, 0. Once we've done bubble sort, we end up with 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And as we've said before, it's a quadratic runtime. So its time complexity at worst case scenario is big O of n squared. Okay, so feel free to leave any questions in the comments. Hopefully this has been informative and useful. It's a very simplistic sort of concept one. Hopefully it wasn't too long. Let me know if you like other sorting algorithms. In fact, I'd like to do probably some more like insertion sort and a few others, maybe merge sort, quick sort, something like selection sort, something like that. But for now, hopefully you've enjoyed this. Remember to like and subscribe if you did, and have a good day. Bye-bye.